In this video we're going to look at cosine. Remember, we have our handy dandy way of remembering all three trigonometric ratios. This is SOH, CA, TOA, and this time we are looking at this part right here, which is cosine is adjacent over hypotenuse. So if I want to find cosine u, as it says here, this time we're going to look at the adjacent side, which is right next to it there, and the hypotenuse, which is the longest side opposite the right angle. So adjacent to angle U is UV, so that's 18, and the hypotenuse is 30. We can reduce both of these because they're both divisible by 6, so that gets me 3 and 5. You'll notice this is a 3, 4, 5 triangle, so that gets me 0.6. And then for cosine W, we get adjacent to W is WV, so that's 24, and that's over the hypotenuse, which is 30. Again, both of these are divisible by 6, so we can write this as 4 over 5, which if we divide those two we get 0.8. And that's that one. So again, cosine U is adjacent over hypotenuse, so it's UV over UW. 18 over 30 reduces to 3 over 5. We get 0.6. And for the second one, adjacent to angle W is WV. That's over UW again. 24 over 30, which is 4 over 5, reduces to 0.8. Here's another problem. We want to string cable to make a dog run from two corners of a building so the dog can run back and forth here. We want to know how long the string has to be. If we know this is 35 degrees and this is 11 degrees, this is going to be one where we have to figure out, are we using sine, cosine, or tangent? Well, if we look at the 35 degrees, that's directly opposite the 11 degrees, and we want to know the hypotenuse, so we're dealing with opposite and hypotenuse. Again, one more time, we've got SOH, CAH, TOA. So we're going to use sine in this case because, again, we have opposite and hypotenuse. So we would say sine of 35 degrees, and then the opposite to that is 11 feet. The hypotenuse is x. We need to solve this for x, so we need to multiply both sides by x. If we do that, the x's cancel, and we have x times sine of 35 is equal to 11. We divide both sides by sine 35, and this is where you get out your handy dandy calculator, because the sine 35s cancel out, and I'm going to have to round this. If I use my calculator, I have 11 divided by sine 35, and I should get 19.2 feet. Okay? So again, for the solution, we write sine of 35 is opposite over hypotenuse. This is also the same as 11 over x. We multiply both sides by x to get this, divide both sides by 35, and then we calculate it. We get our 19.2. So it's about a little over 19 feet of cable. Here's another problem with cosine. We're going to do cosine R. Now R is right here, so adjacent to R is this RT, and RT has a length of 9. Oh, we can't do this. We have to do something first. If you notice, we don't have our hypotenuse, but again, as I've told you, 3, 4, 5 triangle once again. So this is 3 times 3, this is 4 times 3, this has to be 5 times 3 or 15. Now we can do our cosine. So we're going to do cosine r. Adjacent to r is RT, which has a length of 9. The hypotenuse is 15. This gives us 3 over 5, which again gives us 0.6. And cosine S, hopefully some of you already know what the answer to this is. Adjacent to S is the ST, which has a length of 12. The hypotenuse again is 15. Dividing both of these by 3, we would get 4 over 5, and that gets me 0.8. Okay, here's another one. For this one, we still don't know the hypotenuse, so we're going to have to use, it looks like, Pythagorean theorem this time. This is 16 squared plus 30 squared equals SR squared. And give me a sec. 16 squared is 256. 30 squared is 900, and that equals SR squared. Adding those two together, we get 1156 equals SR squared. We're going to square root both sides. And we get 34. So SR is equal to 34. So that's this length right here. Now we can do, let's see, we're going to do cosine of R. So for R, adjacent to R is RT, so that's 30 over 34. And dividing both of those by 2, we get 15 and 17. And 15 divided by 17, by the way, this is another Pythagorean triple. I believe it's 8, 15, 17, but not one you need to remember. That gives me, I'm going to need some room here, 0.8824. Okay? For cosine of S, we know S is adjacent to ST, so we get 16 over 34, which if we divide top and bottom by 2, we get 8 over 17, and calculating that, we get, rounding, 0.4706. Okay? There we go, 4706, 8824. And for this last one, I'm going to need to move it up a little bit. Using the same picture, I know it's hard to see, but we want to use the cosine to figure out the leg of the other triangle. If we go back a couple, we found out that this was 19.2 approximately. So we're going to use that in this problem. So this ended up being 19.2 feet. So in order to use cosine of 35 degrees, now this is, we'll call this y right here because that's our adjacent side. We would say y over the hypotenuse, which is 19.2. Going to multiply both sides by 19.2. Okay, and those cancel, and then we just calculate this with our calculator, and we should get approximately And the answer may be a little bit off from what is in the book, but it should be about 15.7 feet. Okay? Yeah, about 15.7. And that's it. Thank you.